We are good to go.
Thank you. So thanks everyone for joining. And my name is Slava Tykhonov. I'm head of AI at CODATA. And topic of our workshop today is Dataverse, and actually Dataverse ecosystem powered by artificial intelligence. And just also to make sure that you understand that Dataverse is a data repository, but AI is something else. So it was developed in another context, but it could be also reused for other repositories like CCAN and Kaggle, Hugging Face, because we basically made Croissant for machine learning standard, which supports different implementations of repositories. So I will start from a quick introduction of research data management. It's just on conceptual level, it consists of three different things. So first is primary data. This is about objects and data sets which should be preserved in digital archive with persistent identifiers. And secondary data is basically metadata level. It's cataloging when you're collecting data from different sources and you want to publish it and also to make it fair. And another layer is linked open data cloud, where basically you're collecting all metadata and you are able to query metadata, and you can also build sustainable layer, which is powered by linked data. So reuse of research data should follow FAIR principles, and my topic today is about how to make data fair and how to connect AI and how to use AI. So there are a lot of issues and problems in data. I'll not go into details, but for example, essential things like we have a lot of vague variable descriptions. So usually even descriptions are missing. You have like column names like col1, and it's a typical situation for any data set and for any spreadsheet that you don't have any explanation and code book explaining what variable is about. There is also missing provenance. Like you have some files and you don't know from where this file is coming. There are no quality metadata records. There are no cleaning records, and also documentation is usually fragmented. So all of those things could be actually fixed with AI, and I will show you how in further slides. So what really matters for science is you can see from this list starting from FAIR. Right, so FAIR is starting with persistent identifier. So as soon as you're creating data set, some identifier should be assigned and should be persistent, should be solvable. And it should be also, you should be able also to get to the data set anytime, and it should not disappear and should not change. Also, they should be licensed, assigned to data set, and some other things that really essential, like semantics and detailed metadata. So all of that also is being managed by repositories, and Dataverse is really a good example of how we do that. So Dataverse is a FAIR solution. So as soon as you will start to use Dataverse, you'll start to produce FAIR datasets, and you can also connect your datasets to any kind of other systems. You can integrate with different applications, and also you can use AI. Okay, so Dataverse itself is open source project which was developed by International Institute of Quantitative Social Sciences at Harvard University, and it has quite long history, almost 20 years, and there is very cool team basically building all features and implementing new additions, and they're working closely with community. So if you don't know Dataverse, you just go find it and download and install and run. And basically, we made it really simple, so everybody can do this even on laptop. So what is so specific about Dataverse? It's built on API, on application program interface. So that means that whatever you will do in Dataverse, you should be able to do also these API calls, API requests. For example, like search datasets, deposit datasets, modify files. Any kind of functionality is available through API. And this is excellent application also for AI agents. So you can quickly imagine that you can connect any kind of AI agent, explain all this information about how to use API, and basically it will start to do all this job for you. which is very convenient. Oh, by the way, I forgot to mention that put all questions in the chat, so I will be able to respond them in the very end. Okay, so this is a new development. So it's a data observatory from Chile. So we have Rodrigo and Alvaro from Chile here. So we started small experiment, and there is a Dataverse running for data observatory, and we started also to collect data and to deposit data. So if you'll have time, I will show you some practical examples how we can also analyze and connect even to this small data set, which is kind of created on the spot. We can already connect to AI and ask any kind of questions, and it's responding. Okay, so again, so I just wanted to stress that API is an essential thing for innovation. As you see in this diagram, it's evolving all time. And now we have MCP. So I didn't put MCP in this lecture, but MCP is also Model Context Protocol. It allows to connect any kind of sources to AI models. And in our case, I'm using MCP to connect LM models to Dataverse. So it's very useful. And also for integrations, Dataverse is very cool application because you can basically get any kind of data directly from Dataverse and read it as a pandas data frame, for example, analyze in Jupyter Notebook and deposit back in Dataverse. So it's like integration that is really transparent, and you can also share files and share datasets with other collaborators, even from other countries, from other groups. And also, as I said, like you can build this integration which could be connected to AI and ask questions, which is very nice. Okay, so in a way, we are basically going from closed innovation to open innovation. I will not go into details here, but Dataverse is really open, like scope, and it basically forcing innovation because all data which is deposited in Dataverse, of course, with appropriate licenses, they are available, and people can reuse data instead of just producing some isolated data sets. So now I'm coming to important point because, of course, we have a lot of Dataverse instances worldwide, hundreds of them, and more are coming. And we are working on semantic interoperability. And we're trying to implement this on the level of infrastructure. That means that we're working on common standards, which will allow to basically combine different data repositories, even different platforms in data lake. And it's basically distributed, decentralized infrastructure where you can just basically crawl through different implementations of repositories, and you can explain what kind of repository it is and what kind of language it's using, what kind of search interface. After it can navigate through and find data, and you can do something with data by using link data technologies. Okay, so now we're coming to important point of Croissant. So Croissant was specifically designed for data integration. And data integration for machine learning. So the idea behind that, you can basically, if you have some complicated questions, like let's say you need to combine thousands or tens of thousands or millions of data sets, and you need to identify which variables from which columns, from which spreadsheets you need to use. So basically, Croissant allows to describe that, and you will get this in unified format. So you can collect data from different sources, integrate, and train model directly and ask questions, which is nice. So there are also extensions. So currently we're working on semantic Croissant, which is extension related to shared vocabulary support, ontology alignment, and also multilinguality. And there is also CDF integration, which is cross-domain interoperability framework. What I forgot to here. So it's also why Croissant is so important, because it's collaboration between academia and industry. So doesn't matter if dataset is being published on Kaggle, which is owned by Google, we can still get Croissant file, and we can basically deposit this Croissant in Dataverse and use all applications, all available tools to enrich metadata to do something nice, and after we can deposit back in Kaggle or in Hugging Face. So this is interoperability level, which everybody is dreaming of, because you can also use artificial intelligence and combine a lot of data sets coming from different sources. And in Dataverse, it's just a basically button, a Croissant exporter. So as soon as data set is created and published, you'll get this button to download Croissant, and after you can just feed it inside of model, and it will understand Croissant structure, because this is how they're training AI models now. They understand Croissant structure, and you can ask any kind of questions on that. So just in a nutshell, it's dedicated for different for different tools, for training tools. So it's not only LM which could be trained, but we're supporting any kind of frameworks like PyTorch, Keras, TensorFlow. All of that is basically Croissant compatible, and you can just use any dataset in Croissant, put it in Keras, or put it in PyTorch and train model, and after use this model, which is also very, very convenient. So just in a nutshell, we have 4 layers. First is, of course, dataset level metadata. So it's based on schema.org and dataset. And there are also best practices for required fields and licenses and this kind of stuff. Second is resource description, which is where referencing files and archives and remote directories. And also there is support for different file formats. And also content structure, which is agnostic to specific file formats. And of course, machine learning semantics, which is the most important thing. This is where the whole magic is happening. And like for example, labels, variable descriptions, training test splits, all of that is being implemented in this layer. Just to give you an example why it's important and how it works, there is a really small data set, some movies, and basically what is being shown here, you can see some tabular file, and there's a split, and basically you can explain what every column means and how model should be trained, and after you can get this ML semantics described and train new model and ask questions about movie. So this is the idea. So now I'm coming to DDI CDI. So this is also very innovative and new development. So DDI is well-known standard, and it's probably like 25 years old, but DDI CDI is fresh, and basically it's knowledge graph, and it's dedicated for cross-domain integration. This is our backbone for CDIF. So this standard is closely connected to control vocabularies, and especially to multilinguality. So the idea here that there are different platforms, and in this example is Cosmos, which is hosting ELST vocabulary for social sciences. But there are much more vocabularies, and we can publish this in platform, and it's becoming also it's becoming accessible for AI applications, for any kind of applications, and also for Dataverse. So now we can also describe metadata by using control vocabulary terms. From this, we can connect, and this is how we can get all translations or specific term already approved by experts, because it's published on this platform. Okay, so inside of Dataverse, we also started to connect things. So we are building knowledge graph, and we are also converting any fields, even new fields, which is coming into metadata schema of Dataverse. So we're connecting to different ontologies, and like pool or Dublin core, to define the semantics, what is about. So this is on ontological level how it's been done in Dataverse itself, in Dataverse metadata schema. So I already told you about control vocabularies and about ontology. So this is how interface works. So as soon as you're creating dataset and describing metadata fields, and you're coming to keywords, you can just type a few characters, and after you'll have a list of suggested terms, and you can select term, and after it will be stored in Dataverse, and it will be immediately available with all translations, with all properties for any applications, including AI. So it will understand exactly what you mean by this, using this keyword in metadata description. And as soon as you will have this in Dataverse, there is also a possibility to query through linked open data. So there is a framework called Triple Store, where you have all this language, all this knowledge already aggregated and deposited, and it's available for querying. You can just query on any kind of fields, on any kind of expressions. It can also answer some complicated questions as soon as you can create Sparkle, and you can get results back. Yeah, there are also a lot of challenges, like for integration. So, of course, data providers deliver metadata in various formats, and we started to work on Chile use case, and in Chile there are a lot of different ministries that are publishing data in completely different formats. So, also we need to understand them. Then we need to create some mappings. We also need to analyze what kind of variables they're using because they're in Spanish. And we need also to find English appropriate terms in English. So this kind of stuff. So of course it requires a lot of work, and this is where we need to use AI, obviously, with human in the loop. Again, so second challenge, it's disambiguation, because if you'll search for some popular terms, probably you'll get these terms repeated 10 times or even more, and it's very difficult to distinguish which term should be selected and linked and deposited in data repository. So we are also building AI applications to do that can recognize based on context. So basically, if you have description is being taken as a context, an AI model is able to recognize appropriate term, right term, and also to link and deposit in data repository. Okay, so now it's CDIF. So CDIF, as I already said, it's cross-domain interoperability framework, and it's specifically designed to support FAIR implementation for any kind of projects. And CDIF, we're also building CDIF service, which allows to produce JSON LD, which is suitable also for integration with AI. So we started to integrate it with Croissant to get so-called variable cascade available for Croissant, containing all detailed information about units of measurements, properties, classes, attributes, and any kind of information which could be useful for AI. So this is how it looks like. DDI is just XML, and from this XML, we are going to JSON LD, and this JSON LD is being incorporated in Croissant. So Croissant is also JSON LD, but Croissant, you can see Croissant is basically as a digital library. And in the same time, CDIF, so it's digital library, it's like contents in a book, it's a scientific book. But in the same time, if you want to get information about scientific variables, you have to go to the index, to the end of book, where you have all this list of variables, and this is approximately what CDIF is representing. So there is also checklist for Croissant integrated with CDIF. I don't know if I'm still on time, but just quickly again. So persistent identifiers is very necessary in functionality. So we also want to assign persistent identifiers for every variable. We also need to do checksum, and we need to assign licenses, license statements, also to provide context for variables, and we need also data types, a phenomenon description, variable definition, and conceptual links. All this information should be available for successful integration with Croissant. Like second part, we also have schema with table definition, columns, and keys, all this nested infrastructure, nested structure. All of that information should be available in JSON, and should be also incorporated in Croissant to make it AI ready. And provenance, history, and some other things. I will not go into details. You have all information here. So now CDIF demo. So this is where I need basically to switch to my LM Studio. I have it on my laptop. Hopefully you can see it also. Just give me 1 second. You see my screen? Can someone confirm?
Yes, we can.
Okay, good. So what you see here, it's a model context protocol, MCP. Someone wants to ask a question? Oh, okay. So what you see here is called model context protocol, and it's implemented for CDIF. So it's a CDIF as a service. So here I'm asking basically to translate climate change in various languages. And what it's doing here is basically able to recognize that it needs to run translation tool, which I implemented separately. And it's sending to this tool climate change and some other parameters. And it's getting a list of translations. So here you see that climate change is being translated in, I think, in 12 or 13 languages. We can also add more. And currently there is a Mistral model which is doing that, but we can also connect to any kind of models specifically designed for translations. And all of that information could be already used to create concept description for climate change. And it does even more. So for climate change, it's basically able to generate a description. So this description is completely AI created, AI generated, but also it's given SCOTS relationships. So as you see, there is a SCOT broader, like global warming and narrower sea level rise, extreme big weather events. So this kind of stuff is basically coming from model itself. However, it's also it's given identifiers, and those identifiers is coming from LM, from model. So we need to double check to verify this information because we don't know if model, sometimes it can hallucinate, and it would be nice to use a completely different model to double check if it's getting right identifiers. So there is another tool called semantic link. And basically what it does is querying Wikidata for every concept, and it's getting a list of candidates. And basically it's like doing computation of similarity in vector space and trying to predict that this concept could be linked because it looks similar to what we are searching for. So like for climate change, is basically querying, there is separate API and getting linked term, and also doing this for global warming or for other concepts. So basically it's producing semantic links. This is how I call them. And now Wikidata ID is trustable, is coming from factual source, from Wikidata itself. And as you see, when I asked model, so I'm using GPT-OS from OpenAI. So like global warming, it was this identifier and sea level rise. But after I basically verified this Wikidata itself, yeah, it's different. So as you see, it's making mistakes because there is also disambiguation process. So probably it's kind of related according to LM, according to vector space, but it should be, again, so verified by other models. So this is how AI is being implemented, and it's basically double checking itself. Okay, so now because I have, I'll also collect a description from Wikidata about everything, every concept. So now I'm able to ask, okay, so give me units of measurements. If you see like all these indicators, and you see for every relationship, you can find some units of measurements. So this is what's happening here, like global warming. It's also extracting typical indicators from LM. So it's coming from LM, and also it's bringing in like, okay, so this is temperature, should be Celsius, and this is pressure, so should be in pressure, main sea level change. So basically it's giving you units of measurements, and you can verify and you can confirm, and all of that information could be already attached to CDIF representation of variable, and it could be used as soon as verified by human, could be used for AI integrations, for further AI integrations. Okay, so what I will do here, because I was able to recognize, for example, like for carbon footprint, I was able to recognize a few significant indicators. So now I will just go to my Dataverse MCP powered by Croissant, and we'll start to ask about datasets representing that. So like, let's say, yeah, just give me a second. I will try to go to cursor. So this is cursor now. Okay, so this is something else. Just give me 1 second. Yeah, so apparently this is example from Chile. first example. So I was able to talk to chat with a dataset from Chile, and just to give you the idea how it works, I will do it from scratch. So I will ask like find datasets on carbon footprint with indicators like okay. Let's see what will happen. So what you see here is a MCP server implemented specifically for Dataverse. It was created by me in collaboration with Harvard team, and it's using Croissant standard to communicate to AI models. So basically what you see here is a live experiment. It understands what I'm asking, and it knows how to use my MCP. It knows which tools are available and also how to query different dataverses in could be from any country also. I can also specify from which country I want to search, but here basically it just goes in agent mode and trying to collect information about carbon footprint. So now as you see, it's in the process, and yeah, so it will, after it will get all this information, now it's producing results. Okay, so this is what we got from the whole Dataverse network. I will try to increase size. So those datasets about carbon footprint, actually 3,620 datasets, and you see it's basically producing nice overview, and it's also given some examples like, okay, so like key datasets about the topic. So what I will do now, I just want to explore this dataset and ask questions. So like explore this dataset. And this is ID. So I mentioned a few times persistent identifier. So this is called DI, and DI is basically allows basically to cite dataset in external sources like papers. So I'm just asking to explore this dataset, and what is happening here, it will go to Croissant again. It will itself will create request, will get dataset details, and it will understand what it's about. And now you can ask any kind of questions. Could be about metadata, who has created this dataset, when, why, and describe topic. But you can also ask questions about files contents. And yeah, so now it's getting Croissant record and it's producing this code as agent. So after it will produce very nice overview of his data set. You see, so now I see I've got all these descriptive statistics, descriptive metadata, and after it will be some statistics about files, like dataset has 9 files. This is description. So basically it's giving you access to all available information on the spot. And this is available for any dataset published in Dataverse network. And even for newly created Chile Dataverse, we can do the same. So if I'll put a new dataset in this cursor environment and will ask questions, it will give me all these kind of answers. Okay, hopefully this is clear. I can also ask to like, can you show me variables from, let's see if it has some, yeah, from this file. So you can see Croissant as a kind of navigation system in your car. So before driving somewhere, you're basically defining location. So you're specifying city name and after street, building number, and basically this is exactly the same purpose for Croissant. It's your navigator. in the world of AI. And as soon as we'll start to integrate information about variables, it will be able to precisely identify variables that we are looking for, and we can also integrate them in different applications. So I just asked to basically to get variables from this file, and as you see, it's doing job. So basically, it's able to analyze columns and given like faculty identification, company information. So all of that is coming from directly from file because it's accessible through Dataverse API, and this path is being told to AI by Croissant representation. Okay, so I think should be fine. I will switch back to my presentation. Yeah, so this is what I just showed. So I got all these indicators predicted by AI, and for carbon footprint, I'm getting this nice representation. And however, I used different query and also different. I explored different data set. You can try yourself because MCP for Dataverse is open source. You can just go on GitHub and install it and run it with your IDE. Okay, so now questions. I think I'm quite, yeah, I'm quite good with time. So if you have some questions. Do you share PPT? I think I shared a presentation, no?
And we
Yeah, I think that means that it wasn't coming through visually for Catherine. I mean, that was at the start, but now it's fine. But I'm sure it would be good to
Yes, no,
share
it's
the
fine. It was
presentation
at the
afterwards on the recording.
Okay, I will do it again. No worries. I really hope that you got a bit of view and kind of feeling of what we're building, and also this variable cascade that, with Croissant, we can do really cool stuff like data integration and spot from different sources. Esteban.
Yes, thank you, Slava. So my question is, can you ask to the model if the model can find another data set that contains different variables?
What do you mean, actually?
Yeah, for example, imagine that you are interested in some variables. I don't know, for example, some of the variables in climate change related with Portugal. And you are interested to find data sets that they have these specific variables from Portugal in the different dataverses that you have. So you can make a question.
Yeah, that's exactly what I just showed. So basically, I was searching on specific variable on carbon footprint. I was searching in the whole Dataverse network, which is around 150 Dataverses. So this overview is coming from the whole network.
Fantastic.
Yeah, and it's also very detailed on variable level. And the only problem that it should be kind of described in a way like you're searching. So there is no linked data layer yet that allows to find all the synonyms and related concepts and what we call variable cascade, basically consistent of different indicators. So we are going to develop this further.
And just for curious, and sorry for the other question, is imagine that you have not repositories of data, repositories of software. So it is possible to ask to these repositories, or is there any way to ask them if they have some software scripts to manage one of the variables, for example?
So Dataverse supports CodeMeta. So you can put this information in CodeMeta and deposit basically as a data set. So it's data set describing your software. And as soon as it has some mention inside of description, it should be found. And I think just AI will do a good job to do interpretation. So
Wow, that's great. Quite
Yeah.
interesting.
Thanks.
Thank
Simon?
Thanks. Thanks, Slava. Thanks very much for the great presentation. Thanks to Esteban as well for that question. Mine's a little bit more of a comment, but an observation. But I'll end with a question. So when you did the search, okay, what are the variables contained in this data set? Actually, I mean, it scrolled up very quickly, but in fact, it said that it couldn't extract them. And I think, what this means is that we have at our hands, in our possession,
Yep.
huge potential from this tool. And we also have a very significant challenge as well. And that challenge consists in providing those variable definitions and providing those really authoritative semantics. Now, you probably knew that I was going to say that because that's my sort of, my bugbear at the moment. At the same time, the tools that you just showed can help us with that semantic enrichment, with adding that variable definition according to the standard laid out in DDI, CDI, and CDIF, and incorporated and aligned with Croissant. That's what I wanted to stress, and that's the comment part, because that's the sort of something that I want to communicate to our colleagues in Climate Adapt. That this is what we need to do, and what we can do for each of the Climate Adapt data sets, for the data sets with Data Observatory, etc. But then the challenge is, okay, what do we need to do that? How can we get to a stage where we can operationally use the MCP tooling and the AI assistant to enrich those data sets? How can we take those, some of the Thanasis data sets, for example, and make sure that we add the semantics and the description of the variable to those data sets so they can be parsed and searched in that way, and so that potentially they can be integrated in that way. Because the objective that we want is for a search to be able to say, okay, I want all the data sets that are available in EOSC or somewhere else that have this variable. So we can integrate, compare, and contrast the data that we have that's measured a particular thing. That's the objective. It's kind of crazy that we can't do that now, or we can only do that in parts. What's the roadmap so that we can do that?
Yeah, this is really good point, Simon. So I must admit that even not all dataverses contain information about variables, because there is special functionality called ingest workflow, which is disabled because if you have large files, it's taken too much resources, and a dataverse can become not reachable. And so basically, not all people want that. So Harvard Dataverse does that. So you have more or less precise information about variables, including like descriptive statistics. But if you'll go to another country, like I've seen in France, well, only a few dataverses actually enabled this functionality, so you'll not be able to find any variables, and in some other countries as well. So we have really a lot of work to do, and I think we need also to do it from scratch by connecting all these new tools that we are going to develop, like human in the loop. So when basically we're extracting variables, we need to inform original depositors that there is a new shiny feature that can help you describe your data better, and it will get more citations, so your rating probably will increase. And we need to make it attractive for people, so they'll start to use tools, and they'll start to they will start to improve quality of their own data sets. But yeah, it's long way to go, I would say. Thanks. See, Thanasis, you have a question.
Thanks, Slav. It's very exciting stuff that we are seeing. It's very probably simple question, but just to clarify, can you do the same approach with images? So you have a picture or global picture about global temperature, for instance, and if you can somehow put all the semantics behind it, would it be also possible to link it at least to the work that you're doing? And I let alone try to interpret what is there.
Yeah, so it's possible even now to get some information with computer vision from images. So there are some models like there is also GeoGPT project, and Simon in the board of this project, so we can also use those models to try. And basically, we just need to ingest all images in Dataverse and create some metadata description with provenance information, indicating where specific image was taken, or there is some satellite images from NASA, from any other sources. And after we can try to also to use AI like GeoGPT to do some kind of metadata extraction. They're able to do that. I mean, those models already smart enough, and you can get some kind of output already, which could be integrated back in Dataverse again by API, indicating that this is basically artificial intelligence. It's not human verified. And again, so we need human in the loop. We need experts understanding what model is producing and also correcting and publishing as a verified information. So yes, but still it's a long way to go, and we are discussing together. We are working on proposal together with Simon and NASA and Harvard and other people on GeoCroissant, which is kind of extension of Croissant for geospatial research. Okay, so Alvaro.
Hi, Slava. Thanks. Was a very good presentation, and we are eager to try many of those things in our datasets too. Um, if I implement my own Dataverse, could you MCP or your LLM connect to my Dataverse MCP? Do I need to register that in a global environment or some catalog? How do they access any Dataverse available? Just that's something that I don't understand very well.
So there is a registry at Harvard. So they are running and maintaining this registry. It's basically a spreadsheet. So everybody can register own Dataverse in this spreadsheet. And Harvard is doing verification. So after basically they're confirming that this is real in Dataverse and could be connected, accessed, and it will be immediately found by AI. So you don't need anything else. And even if you are not registering, you can always point MCP to your Dataverse and ask, can you basically show me all available datasets on specific topic? And it knows how to communicate to Dataverse, how to search, how to get to specific dataset, how to convert to and get Croissant. So you should be fine even without registration. I can show you if you will have time. I can show how I'm chatting to your data that you sent me.
Yeah, that will be great. Thanks.
Okay, Aziz.
Hi, thanks, Slava, for this exciting presentation. So we are getting a bit more familiar the works you do and those CDI, DDI stuffs. So I mean, I'm just tailoring the question that Thanasis asked about the image processing. So in Climate Adapt for EOSC, we have three use cases, and another service is called Big Data Analytics. Over there, basically, we are developing a number of large vision models, so image processing. So probably this could be an opportunity to check some of this Croissant in the geo field. So we may think on that under this like Climate Adapt for EOSC, we can look into the. I mean, you mentioned that you are developing new proposals with NASA and this sort of stuff, but still, as we are dealing with some geoprocessing information or processing, and then maybe we can check some of your techniques.
Yeah, absolutely. It's, Dataverse is a generic purpose repository. So if you have some specific cases, you can also create your own metadata schema. And as you're not only describing new fields, but you are basically descriptions, and you can also link to some ontologies. So it's basically a very simple application that we're doing quite often to extend Dataverse with new metadata schemas to support these different disciplines. And not only about files, we can do video, for example. So if you have some video, you can upload, and it will recognize that this is MP4 format. So it should be video transcription service or Auto-AI or something else, and you can get back all this textual information and deposit it back again in Dataverse as an open file or restricted file. And you can also run some named entity recognition pipeline on top of that, and also enrich metadata automatically or semi-automatically. So there are a lot of applications, a lot of features that could be used also for our project. Yeah,
it's very good.
Okay, so Esteban, can you elaborate on this? Because I'm also I'm really interested to hear about what you're doing in FAIR to Adapt.
Yes, sorry, Slava. Yes, in FAIR to Adapt, as you know, we are working with I-adopt variables. Okay, so we are developing a service to transform, we can say, the definition, taking the definition of the variables and creating the I-adopt variables. Okay, that is basically a turtle file, but we can export to JSON-LD. So maybe one collaboration could be if you can extract this variables definition from the data that you have in the database, even with the description of the data set, then we can connect it with this module and try to create these I-adopt variables. This is how to share and also a common effort in both projects. I'm just.
Is it already in prototype phase? So we can try.
Not yet.
Not yet.
Okay, but I think in 2 or 3 months we have the models. Okay, we are evaluating right now the models with a benchmark. Okay, and then we will build the service. Okay, so I think in 2 months we will have the evaluation. Okay, at the end of the year.
Nice. Yeah, and I think we really need to work on this together because it makes no sense just to redo the same functionality a few times, right? Sam.
Yeah, I just wanted to add to that. So what Esteban has just said is really important. First, yes, it will be really important for climate adapt for EOSC and for FAIR to Adapt to collaborate as such. That's a good thing, but particularly on this issue of variable description, that will be really important. If the CA4EOSC proposal that some colleagues were involved in preparing is funded, that alignment of I-adopt variable description with the DDI-CDI variable cascade will be an important part. Just in very simple terms for everyone, I-adopt is a really useful approach to modeling what you might call a complex variable. So a variable where there are a number of constraints. And those constraints can be, the classic example is salinity of water, okay? But water at a certain depth, constraint at a certain temperature, constraint at a certain, et cetera, et cetera. So where you have all these factors that are sort of additional features of the variable. Now, DDI-CDI deals with that in a slightly different way, and the challenge is to align it. The problem, well, not the problem, one of the issues that we need to address with I-adopt is that it creates a model, a graph, for each of those variable descriptions. And you can have a solution where you have a registry of all those variable descriptions, which can be referenced, but there's, you can imagine that could explode out of all control. Now, so that needs to be managed. And what I-adopt doesn't do is the neat thing in the DDI-CDI variable cascade, which is establish the relationship between the conceptual variable, how the variable is described, as an idea, and its implementation in particular data sets. And so that's where that alignment, or that somehow that sort of fusion of I-adopt and DDI-CDI could be really valuable. I mean, that's my interpretation and understanding of it, and other people might have slightly different views. So, that would be really interesting in whatever context we do that, whether in the funded project, CA4EOSC, whether as part of whether within Climate Adapt for EOSC, but in collaboration with FAIR to Adapt, that desideratum of sort of somehow fusing this variable description would be really, really valuable. So we can keep our conversation open with Esteban and with Barbara and with colleagues about how we do that.
Yeah, I'm pretty sure that we can also reuse, well, offer our tools already for adapt, and let's see, probably they will find much more use cases, new use cases, which could be applied for that, right, Esteban?
Yeah.
So, I mean, we are really open for collaboration, and we are looking forward to work with you.
Absolutely.
Okay, I see a question from Feroz. Thanks, Simon.
Slava, thank you very much for this wonderful presentation. I saw part of it in another meeting because we are working together in the Climate Adaptation for US project. I have a question regarding the semantic interoperability approach. Did you have the opportunity to work on two different data set, two different database schemas to use the your tool to find the mapping between the elements within these database schemas? So this is one question, and the other question is, so this is at the schema level, right? So do you also have the opportunity to match at the entity level? For example, you have two different data sets, two different data sets coming from two different sources, and then they are referring to the same entities with slightly different name or with local names. There, you had the opportunity to check whether the tool can find the mapping between the same entities.
Yeah. So
Yeah, if you can comment on this.
Like from second question, because this is exactly what I did in one of the projects in the Fair Impact, where I actually built prototype that allows to match like more or less similar concepts. So probably slightly differently described, but still that could be the same. And it's basically a kind of establishing similarity score, which could also pass threshold. So let's say if like you see that there is something which is like more than 90% similar, it could be you can establish link and after use another model to double check. So answer on second question, yes, there is working prototype that can do that. And first question about schema transformations, right? So like mappings. So the way how CDF as a service was implemented right now, it's using intermediate representation with COS. So basically, if you have some variable coming from some source, I'm querying knowledge graph, and in this knowledge graph, I'm expecting that experts will describe kind of similar variable or exactly the same variable, or at least it will look the same. So it will do lookup, and it will get all information like definition and units of measurements, classes, properties, and this will be incorporated as soon as you can match this. This will be incorporated with your variable description and variable.
Does it also provide the similarity, like some a variable defined in one schema is more specific than the other schema, or more generic than the other schema? Does it provide results like this?
Currently, no, because I never actually thought about that to do like different ranking in different schemas. But it's like general right now. But in principle, based on relationships, yeah, I can try to do that also. Yeah.
Yeah, because your tool can already give a lot of information. For example, the related term, the broader term, narrower term. So if similar things, so where we can use all this information. So these information can be really used to identify the relationships, semantic relationships. Then we can really we can really use your tool for enabling semantic interoperability in our projects.
Yeah, I also think so. Yeah, let's try. I think we have a lot of opportunities. Yeah.
Thanks.
Okay, so more questions. Rodrigo, you've been quiet.
Yeah, I will be quiet because I'm overwhelmed.
Okay.
There are so many options. I was talking with Alvaro because maybe Alvaro, you can support me with this because you're more into the Dataverse schema. But we tried to understand how the metadata on Dataverse schema it's built on.
Mhm.
And at some point, I think several years ago, maybe 1.5 or 2 years ago, we tried to search or utilize another kind of schemas because we needed more data, metadata. So my question is, you can use this tool with other different from Dataverse.
Mm-hmm. Yeah.
I don't know if it makes sense.
No, it totally makes sense. Actually, I can show you how I'm chatting to your data directly coming from Alvaro's dataset. Just give me 1 second. I think you will like it. Um, so this is data observatory, and there is a dataset like health statistics.
Yes.
You can see my screen, right?
Yes.
So basically, there are 2 files, one Excel and the second CSV.
Yeah.
Honestly, I have no idea what it means. So I just deposited the Dataverse and it produced some simple metadata. So this is a region. So basically, what I will do, I will ask MCP to produce Croissant, and yeah, I will start to ask questions. So explore dataset. Okay, let's see. So I think it's also original files in Spanish, so she should be interested to see how it does understand. But look, I think it's not bad, no? It's like dataset exploration, so it's able to recognize like this is health statistics from hospital discharge data. So this is author coming from metadata, and this is when it was published. Okay, so contains 2 files. So now, like show me all variables from here. Okay.
Albert, this is the one that Samuel already worked on, or this is
Yeah.
just
No.
from the okay.
It's one of the dataset that is
Yeah, it's
already processed. So
Yeah.
It's
very
this one
very
is
nice.
very yeah.
So look, so I just asked, can you analyze data set? And it's given quite a lot of information. I think it's already quite useful if we'll put this information and we'll enrich metadata description, like with all this stuff. It will become findable. Even with AI, without AI, it will be searchable in Google and with other search engines, and yeah, like all this kind of information is actually useful for search purposes, I think. If it's, of course, if it's true, because we don't know if a model does not hallucinate here, but at least it's kind of nice overview what we have inside. And again, so I basically created this data set on the spot in Australia during one of sessions, and deposited data from Alvaro and created small metadata description. So now I can just get it back, all these variables, and enrich metadata to make it really like looking solid with a lot of information. And yeah, Simon.
Yeah, I mean, I think this goes down to the heart of the challenge and the opportunity at the moment, doesn't it? On the one hand, in a more generic sense, we have this, huge opportunity with these tools and the challenge of training them effectively for scientific purposes. Okay, I mean, I've expressed that in very general terms. Sorry, receiving a phone call. No, I don't want to accept it. So, I think we need to speak to other other organizations and learn from them about how we optimize that model training. Obviously, we have some ideas, the knowledge graphs, the authoritative semantics, the authoritative metadata schema. But there's a lot of work going on there for AI in science, so we need to learn from that. Secondly, within Climate Adapt, and also with our colleagues in Dataverse Observatory, I think we have the opportunity to start testing and building and doing the human in the loop stuff. So, it would be super fun to arrange a time with Feroz and colleagues, and to arrange a time with Alvaro and Rodrigo and colleagues, to start doing some of that testing, to start doing that. So, okay, here's the AI client, here's the data set, here are the semantics. What's it giving us? No, no, it's not good enough. And actually do some of that work. Now, just as a practical next step, I think it would be really cool for us to start doing that. Feroz, with, we can start picking off the use cases in Climate Adapt one by one as we do that, in partnership with Feroz and the semantic interoperability, to try and use as well the ontologies that Feroz has developed as part of that training as well, along with the other schema. So I think we have a work plan that, or we can know what we need to do, but we need to sort of move that to the next step and start doing some of that actual work with it to train the model. And
that sounds like a very good plan.
Outputs.
Yeah, we'll start doing that.
Yeah. I mean, I think some of us are very busy with outputs until the end of the year, aren't there? There's D1.2 and there's D3.1, and it's going to be quite busy. But I think that maybe this is something that we can start in the new year for practical sort of work, and perhaps around the workshop in Aveiro, a little session. Let's see.
Yeah, I think
that's an idea. Yeah,
that's exactly what I
Excellent.
wanted to say. Let's get ready for Aveiro. So in the meantime, before Aveiro, probably by the beginning of next year, we should be getting ready, at least the use cases. We should start preparing all the data we need, all the information we need to have with us.
Yeah. Very good plan. I see a question from Dimitra. Can you also unmute yourself and just ask?
Hi. Yes, I wanted to ask if this way, by querying, if you can query more than one data set. This is one question. And the other is, if you have two different same variables but different names, if we can avoid that and can understand that this is the same variable.
Yeah, so
have similar descriptions.
So to ask first question, so like if there are two different variables with similar description, you need relationships. So this is basically knowledge graph. So you need to build knowledge graph, which we call variable cascade. We want to have all these, let's say indicators, all these variables connected together, and this is how you can distinguish if it's still the same variable or it's slightly different, and you have to create another name for it. Okay, and second question about query. Simon, you wanted to elaborate on this?
Yeah, I think if I may, it's probably a good point to come in, and sorry to jump in, but I think it's worth saying that this use case that Dimitra has described is precisely what the variable cascade is designed to deal with. So yes, there may be some semantic difference in the description of the conceptual variable, and that's where that can be dealt with other semantics, similar to or whatever. But as we go down the cascade, the cascade is designed precisely to deal with that sort of semantic slippage. So where you might have a variable that uses a different unit of measure, essentially the same definition, but different unit of measure, or it might have a slightly different definition. So when colleagues from the DDI world explain this, one of the examples that they use is marriage. And the definition of marriage, married, or whatever, has changed over time. And therefore what it means in particular data sets has changed, in time series data sets has changed. And so the variable cascade is one of the tools, along with other semantics, which allow you to account for that semantic change in a longitudinal sense, and sometimes semantic slippage between different databases. So that's, in theoretical terms, what it's designed to do. Obviously, in terms of implementation, you need specific semantics that describe those differences.
Yeah, thanks, Simon.
Okay, thank you.
And I will ask on a second question regarding integration of two different data sets. So basically, every data set has own Croissant representation. So you can also request them. You can, because it's JSON LD, so you can put them in also separately in a triple store, and you can query them separately, or you can integrate them also in some kind of application like in Jupyter Notebook. So there are really a lot of applications, and yeah, you can also ask AI basically to combine two things together and ask some questions. So yeah, should be fine, should be working.
Yes, if we combine them, it's easier. That creates an environment that interacts with the dataset.
Yeah, but we can also do that, of course. Yeah, Croissant actually was, as I was already stressing, it was designed to combine different data sets and together and train a new model. It was the purpose when Google initiated the creation of Croissant. Okay, so we are coming to the end of meeting. So last question, if you have some question.
I have one last question.
Okay, good.
So it is about, what people in the semantic web community might look for. So they might say, okay, your tool is good enough to find corresponding variables into different data sets. That means we can also ask natural language query, and it can reply really effectively to the natural language against the natural language query. Can we now perform the same query using SparkQL? So do you think that you can go to the next level?
Yes.
Just to, reply against the SparkQL queries that might come against these data sets?
Yeah, so basically, I did that already. So I have AI which is constructing Sparkle queries, and it's querying factual. It's querying triple store to get factual data, and this data you can also integrate.
No, triple store is fine. So that means, of course, we all know that triple stores are designed to reply to SparkQL queries. But what I'm saying, you have two data sets, raw data sets, let's say CSV files. And you have the question that Dimitra asked. So you have two different variables. It's the same variable named differently in two different data sets. Now you're asking a natural language question. Of course, it can return you based on the based on the variable name. So it resolves that the two names are referring to the same variable. So it can reply to your question. And then if you ask a SparkQL query instead of a natural language query, so then it, of course, does some processing. Probably it then ports this data to a triple store, and then it can answer to the SparkQL query, right? Is it the current mechanism?
Yeah. So she should be.
Okay. Okay, yeah, of course. In that way, of course, it can do. Yeah. I was thinking like avoiding the triple store, and then translating this SparkQL query into a natural language query, and then asking it to reply.
Yeah, I understand. Yeah. So modern models like GPT-OS, they're actually quite good with Sparkle, apparently. So
okay.
I saw some hands.
That was me, Slava, just putting variable cascade references in the chat for Dimitri.
Oh yeah, Tom wants.
Yeah, Slava, this is a general question, because I think that was a really a fantastic presentation, very, very interesting, and the kind of thing that I think we would like to put forward to talk about on the communication materials that we have. So we have prepared a little blog post about your presentation. We are not the experts, and so we'll share that link with you. And if that's okay with you, could you just quickly look over that, correct anything that needs correcting, and then we can put that out on the website. The other thing that we just wanted to include in that little presentation, the video that you shared the other day. Is that okay? I mean, do you have any objection to that?
Absolutely, yeah.
Okay.
I mean,
all right.
It's Friday evening, but I will spend some time, so I can help. No problem.
Okay. Very good. Thank you then. That's all. That's it from me.
Can I come in on a related topic? There was some confusion as to whether we would do this meeting, this little workshop, as a public event or as an internal event. I think we felt that in the first instance, it was best largely doing as internal. I say sort of internal climate adapt, but we do have our colleagues from Chile and Esteban from FAIR to Adapt. But we wanted to do it with an engaged audience, or at least an audience with which we could have participants with which we could have very specific follow-up. That doesn't mean, so that we as a project and as a set of collaborations have the first, discussion about how we take this forward. But that doesn't mean that we wouldn't be, I'm putting words into Slava's mouth, and I hope he'll agree, that we wouldn't be, it would be a good idea to do a sort of a more public version at an appropriate time, So that's just a message to Tom and Clotilde and colleagues that, that would be a good thing to do sometime. I think we might want to do some of the work that Thanasis and Feroz have mentioned around Avero first. So we've moved things forward a little bit as a project, but we'd be very happy to disseminate what we're doing.
Yeah,
Can I say
definitely.
something? I think from my side, I think it's nice if we have one of the use cases moves forward and be like the one that we demonstrate. And we demonstrate it with our own use case, and we try to apply all these different tools that each of the partners is going to present, but do it with the data we have, or some of the services and the data we have. I think this is something that we should aim for.
That sounds good to me.
Yeah, I think as soon as we'll start deposit something in Dataverse, or we can also use CCAN after.
Slava, do you think if we can sort of having like a climate adapt for EOSC Dataverse or something similar, so we can, or it's too far away from what we are saying now?
I mean, I'm working with Dataverse community for 10 years. I can basically install everything when I'm sleeping. So.
Okay. No, I mean, the work that we do in Aveiro. So probably if this is something very specific and it's there. So okay, we can maybe we can do it internally first, and then we can make it more.
Yeah. So let's start with some internal test. I would say some development version. So we at CODATA, we have on dev.codata.org website. And as soon as everybody will be happy with quality, and so we'll start consume data and connect services, we can also make it public. So with public announcement that this is specific Dataverse for climate change. So please come to us and try our data sets, because they're created with AI, but also with human in the loop. So there's a high quality. And I'm pretty sure that, it will come popular as soon as we'll do right things.
I think so, yeah. I totally agree.
Okay, good. So no more questions.
Friday afternoon, we know that.
Okay, so yeah, let's finish the meeting, and thanks everyone for participating and for your questions and for your attention. Yeah, I really hope that it was, I've got quite a lot of critics in the past because I'm very technical, and especially like
this one was not technical for me, at least.
Okay, and I'm really happy to hear that. Okay, thanks everyone.
Thank you, Slava.
Fantastic.
Okay.
Thank you for the presentation.
Thank you, everyone.
Thank you.
Thank you.
Bye.
Bye.
Bye-bye.
Bye.